proof. Yesterday we talked about planning our proof and how we set this up. So let's do the same thing here. Now we do have one statement that's a little bit tricky here in our given. It says BZ and LT bisect each other. What does that mean? What does bisect mean? They go through the middle. It's more than just intersect. It's more than just cross. They cross exactly at the center point. So what segments are congruent because of that statement?
Li and IT.
Okay, so I'm going to mark that. Li is congruent to IT and BI to IZ because they're bisecting each other. Okay, not just one being bisected, but they're both being bisected. So let's take a minute then and let's translate that information that we've drawn in our picture into our proof. So we start with our given. Segments BZ and LT bisect each other. And that is given. And so what we concluded from that was that BI was congruent to IZ and LT, or LI, is congruent to TI. Okay? Pardon?
I did those in two seconds.
That's okay. They can be two separate. They're the same. The reason you can do them the same is it's the exact same reason both times. What's the reason we're using that? No. Bisector, yes. Well, a lot of people make that mistake. Okay? But the reason why it's not midpoint is because what word did we use here? Bisect. Okay? Even though they kind of work the same way, the word that was used was bisect. So that's the definition we're going to use. If it had been midpoint, if it had said that I is the midpoint of LT and BZ, we'd have the same conclusion, but then it'd be definition of midpoint as a reason. All right, great. We've got those facts, we've translated them. What else do we have in this picture?
Vertical angles.
Okay, we have our vertical angles. So let's translate that into our proof. Angle LIB is congruent to angle TIZ. And what's that reason?
Vertical angles theorem.
Vertical angles theorem. Okay? Not just vertical angles. It has to be the theorem because we're including congruent angles. You could also say vertical angles are congruent. That's okay. Now, do I have enough information for a shortcut? Which shortcut? SAS. So I got that, and now I can go ahead and say triangle BLI. I can just copy down what's up here. Is congruent to triangle ZTI. And we have our triangle congruence proof. Now, this is where we're starting to see that transfer of what we did yesterday of planning the proof into actually writing the proof. So things are starting to come together now in our proof writing. The real question becomes, and I'm going to have to use my computer for just a second here, what next? So what happens next? Whoa, that wasn't what I meant to do. There we go. All right. Next, what I want to do is I want to go beyond that. And that's what's new today. I want to say, now that we know the triangles are congruent, what else can we conclude? And this goes all the way back to section 1 of the book. When or not section 1 of the book, section 1 of the chapter. But we started out, remember, in chapter 5, section 1, with this. Oh, if I have two triangles that are congruent, what do I know about them? Well, I know, therefore, all of their corresponding parts were congruent, right? I mean, we just started out with, okay, triangle ABC is congruent to triangle QRN, okay? And we said, well, what do we know is true about those two triangles? And we listed all the corresponding parts. We said, okay, we know angle A is congruent to angle Q. We know angle B is congruent to what? R. And angle C is congruent to angle. And we also knew that AB had to be congruent to QR. And RN had to be congruent to BC. And AC is congruent to QN, right? And that's what we did in section 1. Well, we're kind of going back to that now, saying, all right, now I know the triangles are congruent. I knew, as part of proving that with my shortcut, I knew these pieces were congruent. We did that. That's all up here. But what I don't know is I didn't know about BL and TZ. I didn't know about angle B and angle Z, or angle T and angle L yet, did I? But now that I have this statement, this guarantee that the triangles are indeed congruent, now I can move beyond. And I can say, oh yeah, because the triangles are congruent, now I know, for example, angle L is congruent to angle T. So this is our new conclusion. And my reason we're going to use here is the definition of congruent triangles. But that's a lot to write out, definition of congruent triangles. So we have an abbreviation that goes with that. It goes, well, let me explain where it comes from before I tell you what it is. The definition of congruent triangle says corresponding parts of congruent triangles are congruent, or corresponding parts of congruent triangles are congruent. Cpctc is my shortcut that I use. And then that's really an abbreviation. It's not really a shortcut, it's an abbreviation. SAS is a shortcut. Cpctc is an abbreviation. If you can't remember Cpctc, every other letter is a C. P comes before T alphabetically, so P comes before T there. If you can't remember, you could always just say definition of congruent triangles. I mean, it's not that much to write if we use symbols. Okay? But that's where we're going today. We're saying, okay, now that I've proven the triangles are congruent, can I prove that other parts must be congruent? And the answer is yes. And my reason is definition of congruent triangles. It's like we're going full circle right back to section 1 of the chapter. Right back there. So that's kind of what we're doing today. But we're going to do a lot of practicing to prove the triangles are congruent first. A couple notes. Cpctc is not a congruence shortcut. I cannot use this abbreviation to show that triangles are congruent. I may only use that after I have a triangle congruence statement. So a lot of times I draw that kind of dashed line in there to indicate, okay, now I know triangles are congruent. Now definition of congruent triangles is in play. Now I can use that. I can't use it until after I have triangles congruent. I can't use this as a reason. It's not one of my triangle congruent shortcuts. It's after that. All right? Let's look at another one. We're going to do this one together. I think you're going to find this one pretty straightforward. Even easier than the last one. All right. We're given two things which are very easy and very obvious. So we're just going to write those down right away. AB is congruent to BC, and AD is congruent to CD. And that's given. By the way, when you're writing proofs, which you will do manually on the test, remember that you have to number your steps. That is part of the requirement. Okay? All right. And that's already marked in the picture. That's fantastic. What else do we see in the picture? Yeah. BD is reflexive. Yeah. I mean, not only did you identify the part, but you identified the reason why right away, which is awesome. How am I going to write that? BD, I'm not going to write BD as reflexive. I'm going to write BD is what? Not equals. Congruent to BD, and my reason is reflexive. Notice I put 3 lines there, not just one. If I had just put 1 line there, what I would be implying is that BD and AD are congruent as well. Right? Because I already have 1 line used here and here, right? The 1 line is implying or telling me that those 2 segments are congruent. If when I do this, I just put 1 line there, I'm implying that those are congruent as well, which is not what I'm trying to imply. All right? Do I have enough information for a shortcut?
Yes.
Which one? SSS, yes. So I'm actually getting my proof, put my shortcut down first. Now, I have a little difficulty here. I'm used to having proved the triangles are congruent here. And then I just copy down whatever's there, but it's not there right now. Let's just prove angle A is congruent to angle C. It's okay. We're still going to prove triangles are congruent first. We're always going to go for congruent triangles first. So I have to name my congruent triangles, but now I have to do that whole naming thing on my own. Very scary. You have to name triangles all by yourself. Can you handle it? No? Okay. Then I would suggest curling up in a ball and crying. That would be the correct solution. Until you fall asleep because you're just so tired from weeping. All right. But if you think you can brave it out, somebody give me a name for one of the triangles. ABD. What would the second triangle be then? CBD. Okay. Now, we have congruent triangles, don't we? You don't have to draw this line in here. I'm just doing to indicate that we've accomplished our first task with a triangle proof, proving the triangles are congruent. Now what suddenly becomes available to me? We've unlocked an achievement, haven't we? Cpctc now becomes an unlocked achievement. And it's probably going to be what we're going to, I mean, it's not always what we're going to use next, but it's 99% of the time what's going to come next. And what can I conclude? Well, look at the statement. Angle A goes with angle, yeah. Which is what we're trying to prove. Our proof is now finished. Because we've been able to conclude that thing that we are trying to prove. Okay? Now, I could have just as easily said angle ABD is congruent to angle CBD, or ADB is congruent to CDB, but that's not something I'm interested in A congruent to C. That's what I'm really interested in. And why was I able to use just 1-letter names for those angles? Yeah, there's only one angle with that vertex. So I'm able to shortcut a little bit. It helps. So look at that. Only 4 steps, and I got triangle congruence and another step beyond in just 4 steps. Fun. All right. Take a minute and try to do this one. Okay, just on a piece of paper real quick. I'll give you just like 2 or 3 minutes. It's going to be a little quiet in the podcast. People who are listening, you might want to fast forward ahead till you see me writing again. But for the moment, I'm going to have students just work on this on their own. Just do your best. It doesn't have to be a perfect picture. Here's a hint. Draw this line. Draw this, so they're about the same, and then draw your line down here. And then draw those.
Oh, okay.
Again, remember, don't try to write the steps and reasons first. Use your picture, mark things in, reason it through, and then once you've got things kind of sorted, then you can start writing. So make a plan before you write. Really, this is just like English class, how they teach you with essays, how you kind of plan out your essay before you start writing it. You kind of diagram it. And this is what we're going to do. I'm going to do this point, this point, this point, and then you do it. Then you write. Make a plan before you write. Put that away. Yes, you're right. I'm going to start making a couple marks up here just as a hint. Those are just my givens.
Wait, aren't these the same? Aren't the top angles the same as your...
Angle QRT and angle SRT?
Like, yeah.
Well, yes, we could make that conclusion. What theorem would we use for that?
Wait, where? Like,
Here.
yeah.
You could say that this angle is congruent to that angle. You could, yes.
Because we already...
That would be because you have two angles. Yeah, that's called third angle theorem. That's not really going to be helpful to us because angle isn't one of our shortcuts. Okay, angle. Remember angle dilation?
Oh.
Angle could be bigger or smaller. It's not necessarily congruent. Angle is similar. Okay, so that's it. So you're not wrong if you were to say that those two angles are congruent, but it's just not helpful in this case. Yeah, you'd be adding things that aren't helpful.
How did you get angle QTR to...
Because it's given.
What? That's no fun. They give us too much stuff.
Oh no, we wouldn't want to give you too much. All right, so what did you come up with after? What else are we getting from the picture? What these guys were talking about, in case you missed it, is could you say that these two angles right here are congruent? And the answer is, yeah, I could conclude that because if I know two angles of one triangle are congruent to two angles of another triangle, their third angles must also be congruent. That was third angles theorem. That's true. It's just not very helpful in this case because angle is not one of my shortcuts. Is it true? Yes, but just because something is true doesn't mean it's helpful in a proof. What is true that is helpful here? Yeah. Yes, very good. RT is congruent to RT. Okay. I have three pieces. Do I have a shortcut? Oh, by the way, what was the reason there? Reflexive. I count angle 1, angle 2, the two angle T's, and the segment. So which shortcut do I have? So how did you write your congruent statement? Triangle QRT congruent to triangle SRT. Now, I heard somebody say TRQ. That's fine if you did TRQ first. You just have to do TRS as your second one. Or someone said RQT. That's fine for your first one. Then your second one has to match RST. Okay? It's really kind of your choice. All right, fantastic. We got that. I got my congruent triangles. Therefore, what are we going to use next? Cpctc to conclude that QT is congruent to ST. And again, we know QT, ST. It's right there in my congruent statement, isn't it? You getting the idea on this stuff? Yes. Okay. This one's challenging, and I'm going to not make you do this one on your own. I'm going to kind of walk you through it. Because how many triangles are in this picture? There are 8. There are 8 triangles in this picture. Okay? 1, 2, 3, 4, 5, 6, 7, 8.
Wait, whoa. Where's the 7th one?
Top. CDA.
Oh, okay.
Okay? So there are 8 triangles in that picture.
That's so close.
Okay? So, what we have to do here, I want to now, notice I'm trying to prove the triangles are congruent. So it looks like, oh, I just got to find a shortcut for those 2 triangles. But the problem is, I want to prove BCE, which is this triangle, is congruent to DCE, which is this triangle. And the problem is the only thing I know about them is I have the congruent angle, I have a shared side, but that's it. I don't have enough information. So what I have to do is I have to start by proving that other triangles are congruent, then use Cpctc to use additional parts, and then I'll have enough parts. So this is tricky, but I want you to see this. And again, this is probably harder than anything we'd see on a test. So what do we always start with? We always start with our givens. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Okay, that's already marked in for me. Now, when I look at what's given, angle 1 and angle 2 are these, angle 3 and angle 4 are here, but that's really dealing with this triangle and this triangle, isn't it? And if I look at those 2 triangles, what do they have? Shared side, which is CA. Okay, we wouldn't use 3 letters for a segment, it's always just 2. So CA is congruent to CA, that's reflexive. So now I have angle, side, angle, don't I? So that gives me triangle CDA is congruent to triangle CBA. Awesome. I'm going to draw my little line in there. Now I can use Cpctc. Now, here's where I got to think strategy. All right, fine. I've got those triangles that are congruent. Remembering, I want to go for these 2 triangles. Really, I'm looking for this triangle and this triangle. Oh, should have given me a better color. Let's try again. This triangle. Well, I already have angle 1 and angle 2. And now from this statement, I know CD and CB have to be congruent parts, right? Because these 2 triangles are congruent, CD and CB are corresponding parts. So now I know CD segment is congruent to CB because of, what's our reason? Okay, and we have that reflexive side right here, CE. No, we did CA. Yep, that's why this is a tricky one.
Isn't that the same line?
It's still reflexive. Not the same it's the same line, not the same segment. Okay, CE is the short part, CA is the whole thing. Segments have to be exactly the same beginning and end point, be the same. They are part of the same line, but they are different segments. And now, I have this congruent to this, and I have this congruent to that, and I have the angle in between. Now I have side angle side for triangle BCE. I can't write. This is congruent to triangle DCE. Okay? Now that's a pretty tough one. That one's pretty tough. That's the last slide. But it's just an example of how we can, when we get these complex pictures, sometimes you have to start by proving not the triangles we want, by proving other triangles are congruent. We find what we can prove congruent, and then we use that information to get more parts, and we're just always building more parts until we can get what we're looking for. I just couldn't go directly from A to B. I had to go through something else. Yeah, question? Discussion, okay. All right, so that ends our examples for this. However, I do want to go over some stuff. I'm going to end the podcast here. I'm going to go over some stuff from the homework last night, but I'm going to end this first.